Section 4.2 is a little bit deeper dive into the unit circle. In our first table, we're going to be looking at all of our angles that are 45 degrees from the x-axis. So that is going to be 45 degrees, 135 degrees, 225 degrees, and 315 degrees. Throughout this whole unit, we'll be looking at SOHCAHTOA, which is our mnemonic to remember that sine is opposite over hypotenuse, cosine is the adjacent over hypotenuse, and the tangent is the opposite over the adjacent sides from the angle. So in our degrees, we have 45, 135, 225, and 315. Those translate in radians to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, for a 45, 45, 90 triangle, our sides come in the ratio of 1, 1, and the square root of 2. So this side is -1, this side is -1, this is 1, and this is -1, and all of my hypotenuses are the square root of 2. So when I am looking at sine of theta, which is the opposite over the hypotenuse, my opposite is going to be 1 for all of my sides, maybe with a plus or a minus, and then my hypotenuse is the root of 2. When I rationalize that, I multiply both the top and the bottom by square root of 2, so I'm left with the square root of 2 over 2. So when theta is 45 degrees, it's a positive root 2 over 2. When theta is 135 degrees, it is also a positive root 2 over 2. When theta is 225 degrees, it is a negative root 2 over 2. And at 315, it is also a negative root 2 over 2. When I look at cosine, I'm going to have the same ratio between adjacent and hypotenuse, since the two legs on a right triangle with 45, 45, 90 are the same. But the signs are going to be a little bit different. In quadrant 1 at 45 degrees, it's still going to be positive. But now 135 cosine is going to be a negative root 2 over 2. And then in quadrant 3 at 225 degrees, it is negative root 2 over 2. And then in quadrant 4 at 315 degrees, it is a positive root 2 over 2. Now for my tangent, it's going to be the opposite over the adjacent, and all of the opposite sides and the adjacent sides are going to be in the ratio of 1 to 1, so we just have to look at positives and negatives. So at 45 degrees, both x and y are positive, so this is a positive 1. In quadrant 2, 1 is negative and 1 is positive, so it's -1. And then positive, and then negative. In our next table, we'll be looking at 30, 60, 90 degree special right triangles. So 30 degrees, 150 degrees, 210 degrees, and 310 degrees are all 30 degrees off from the x-axis. So converting those into radians, I get pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Again, we're going to be looking at our ratios of the opposite sides of the hypotenuse, and if you remember that in a right triangle with 30, 60, 90, they come in the ratio of 1, 2, and the square root of 3 for my sides. So the opposite side from that vertex is going to be 1, so the top of my fraction for my sine is going to be 1 for the opposite side, and my hypotenuse is always going to be 2. However, in some of our quadrants, we have some negative signs. So in our first quadrant, 30 degrees, both 1 and 2 are positive, so it stays positive. At 150 degrees, my x value doesn't matter. I'm just looking at my y, which is still a positive, and then my hypotenuse is a positive too, because I'm just looking at the distance, so it stays positive. Now, in quadrants 3 and 4 for 210 degrees and 330 degrees, because I am going in the negative y direction, these are going to be negative numbers. For my cosine of theta, these are all going to be in the ratio of my adjacent, so my x value is the square root of 3, and my hypotenuse is 2 for all of these. And then we just have to look at which ones are positive and negative. In this case, in quadrant 1, my x is positive, so it stays positive. But in quadrants 2 and 3, we have a negative sign. When we look at the tangent of theta for these 4 angles, my opposite side, just like we used in our sine, was 1, and our adjacent side is the square root of 3, which we need to rationalize, so that is going to be the square root of 3 over 3. For all 4 of our angles here, that same ratio will apply until we look at our positives and our negatives. So in quadrant 1, both x and y are positive, so tangent is positive. In quadrant 2, for 150 degrees, my x is negative, but y is positive. In quadrant 3, both x and y are negative, so I'm left with a positive, and in quadrant 4, I have a negative. Next, we're going to look at some 30, 60, 90 triangles, but where 60 degrees is our angle from the x-axis. So those are going to be 60 degrees, 120 degrees, 240, and 300 degrees. Now in these, we still have the ratio of 1, 2, and the square root of 3. However, they're going to be flipped a little bit from before. So we're still using SOHCAHTOA. And now, so for my angle in radians, let's convert those. So those are pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Our sine is going to be the opposite over the hypotenuse, and so that is going to be the square root of 3 over 2. And again, that same ratio is going to apply for all of these in this particular table. And then all we have to do is look at the positive and negative signs. So since y is looking at our y values over our hypotenuse, we're just going to look at the y side. So in quadrant 1, y is positive. In quadrant 2, y is positive. In quadrants 3 and 4, we have a negative sign. Our cosine of theta is looking at the x, so we can look at our x values and we can actually put our sine values in, our pluses or minuses in before we do the values. So in quadrants 1 and 4, x is positive, and in quadrants 2 and 3, we have a negative. And because we are looking at our adjacent over our hypotenuse, it's now going to be the ratio of 1 over 2 in all of these. Next, we get our tangent, which is going to be y over x. And all of these are going to be in the form of the square root of 3 over 1, which just equals the square root of 3. And then we just have to look at our y over x. If both y and x are positive, such as in quadrants 1 and 3, this is going to be a positive value. In quadrant 2, my x value is negative while y is positive, and in quadrant 4, the opposite is true. Next, we have some very special angles whose terminal side lies on either the x or y axis, so they're not in any quadrant, they define the edges of our quadrant. And so those are 0 degrees, which in radians is also 0. We have 90, which is pi over 2. 180 degrees, which is pi radians, and 270 degrees, which is 3 pi over 2. Now, remember, sine is going to be talking about our y values over our hypotenuse, and in this case, our hypotenuse is always 1. And then our cosine is x, and our tangent is our y over x. So for sine of theta at 0 degrees, there is no height, so sine is 0. That is also true at 180 degrees. At 90 degrees and at 270 degrees, our y value is exactly 1 on the unit circle, so those are 1. But negative when theta is 270 degrees. For our cosine values, when theta equals 0 degrees, x is exactly 1. At 90 degrees, x is 0. At 180 degrees, x is negative 1. And at 270, x equals 0. So now we're going to take those ratios of y divided by x and see what we get. So when y equals 0, y divided by x is also 0. But when our cosine of theta is 0, I have an undefined fraction because I can't divide by 0. So I actually do not have a defined tangent of theta when theta equals 90 degrees or 270 degrees. Since the unit circle has a center at the origin and a radius of 1, so when x is here and y is here, using the Pythagorean theorem, we get the equation x squared plus y squared equals 1. So on a unit circle, when r equals 1, the cosine of theta just becomes the cosine theta equals x because r is 1. And the sine of theta just becomes y. So for any point on the unit circle, our x-coordinate can be defined as the cosine of theta, and its y-coordinate is the sine of theta. So now we're going to use these, and we're going to write as coordinate pairs what each of these special angles looks like. First, let's just start at 0 degrees, or 360 degrees once we go around all the way. And that equals 0 radians, and we're just going to list our angles. Our next one here is 30 degrees, or pi over 6. Next we have 45 degrees, which is pi over 4. Then we have 60 degrees, which is pi over 3. Next we have 90 degrees, which is pi over 2. And then we're going to keep going into quadrant 2. So 2 pi over 3 equals 120 degrees. Then we have 135 degrees, which is 3 pi over 4. And then we have 150 degrees, or 5 pi over 6. And then we have 180 degrees, or pi. Now we're into quadrant 3, and we have 210 degrees, which equals 7 pi over 6. We have 225 degrees, which is equal to 5 pi over 4. We have 240 degrees, which equals 4 pi over 3. And then we get to 270 degrees, or 3 pi over 2. And now, finally, we're into quadrant 4, and we have 300 degrees, which equals 5 pi over 3. And then we have 315 degrees, which equals 7 pi over 4. And 330 degrees, which equals 11 pi over 6. So those are all of our angles. And then we're going to go through, and we're going to do our xy coordinates. So at 0 degrees, x equals 1, and y equals 0. At 30 degrees, x is the square root of 3 over 2, and y is 1/2. At 45 degrees, both of those are the square root of 2 over 2. At 60 degrees, we have 1/2 and the square root of 3 over 2. At 90 degrees, we have exactly 0 and 1. At 120 degrees, we have negative 1/2 and the square root of 3 over 2. At 135 degrees, it's now negative square root of 2 over 2, and then positive square root of 2 over 2. At 150 degrees, we have negative square root of 3 over 2, and then 1/2. And at 180 degrees, we have exactly negative 1 and 0. As we keep going around the unit circle, now you'll notice as we reflect this circle from the quadrants 1 and 2 into quadrants 3 and 4, we'll keep those same ratios, but the negative signs will move around. So At 210 degrees, we have negative 3/2 over 2 still, but now negative 1/2. And then to keep going, it is negative square root of 2 over 2 and negative square root of 2 over 2. For 240 degrees, we have negative 1/2, but negative square root of 3 over 2. And then at 270 degrees, we have exactly 0 and negative 1. Finally, in quadrant 4, we have at 300 degrees 1/2 and the negative square root of 3 over 2. At 315 degrees, we have the square root of 2 over 2 and negative square root of 2 over 2. At 330 degrees, we have the square root of 3 over 2 and negative 1 over 2.